Good afternoon, class. This is Algebra practice test number 4, module 4, covering chapters 9 and 10. Chapter 9, quadratic functions. Chapter 10, exponential and logarithmic functions. Starting with chapter 9, quadratic functions, we want to answer the following. F of x is given x minus 1 quantity squared plus 2. And the second one, x plus 3 squared minus 8. We are interested in finding the vertex. This is the vertex format for a function. F of x is a times x minus h quantity squared plus k, in which case h and k would be the vertex. So this will give us 1, 2. According to this will give us -3, -8. Determine the number of real solutions for this function. So let's discuss the quadratic formula, which is in the form of ax squared plus bx plus c equals 0. X is minus b plus minus the square root of b squared minus 4ac over 2a. And what's under the radical? B squared minus 4ac is called the discriminant. If it's positive, we have 2 real solutions. If it's 0, we have 1. And if it's negative, we have no real solutions or 2 complex solutions. And one more thing, when b squared minus 4ac, when this expression is a perfect square, that means the expression can be factored out. So first, you have to move the 6. Then a is 2, b is 3, and c is -6. Plug it into this formula. This is 9. This is -4 times 2, -8 times -6 is positive 48. 57 is positive. There are therefore 2 real solutions. We want to graph this function. So we are asked to find the x-intercept, the y-intercept, the vertex, determine whether it opens up or down, axis of symmetry, so on and so forth. So to do that, let's quickly recap what we learned about quadratic functions, which is in this form, ax squared plus bx plus c. The graph is called a parabola. If a is positive, opens up. If it's negative, opens down. When it opens up, the lowest point, and when it opens down, the highest point, those are the vertices, or vertex for this one, vertex for that one. Coordinates, the x coordinate is x minus b over 2a. I like to stick with that only, plug it in, and now I have the y coordinate, or you can memorize the formula. 1 is good enough, x is minus b over 2a, and plug it in. This is called an axis of symmetry, which has the equation x equals minus b over 2a. In other words, when you find the vertex and you write x equals that, that is the axis of symmetry. It's a line that divides the graph into 2 symmetrical halves. To find x-intercept, you set y or f of x equal to 0, y-intercept, x is 0, and notice if x is 0, the answer is c, therefore 0, c. Domain is always all real numbers, but the range, it depends. If it opens down from -infinity up to the y coordinate of the vertex, if it opens up from the y coordinate of the vertex all the way to infinity. So to do this, let's start with intercepts by setting m equal to 0. It's an easy factoring. We want 2 numbers. The product is -5. The sum is -4. So x becomes -1. X becomes +5. Because we are looking at intercepts and we don't want any confusions, we write them as pairs. This means -1, 0. This means 5, 0. And for the y-intercept, if you replace the x with 0, you get 0 minus 5. So those are 3 important points we got. The vertex, x is minus b over 2a. Remember, a is 1, b is -4, and c is -5. So minus b is negative 4 over 2 times 1, and negative times negative, they cancel each other, and we get positive 2. Plug in 2 squared minus 4 times 2 minus 5. This is 4 minus 8 minus 5 is negative 9. The vertex is located at 2 comma negative 9. And also remember here we said A is 1, so it opens up. Let's write the synopsis of everything. All those points are there. For now, I want you to ignore the last one. I'll explain why I came up with that and how I came up with that. This is your y-intercept and the x-intercept and vertex and the second x-intercept. So starting with the vertex, and remember it opens up. We said A is positive 1, so we know it opens up. So this is the bottom line. So let's write the two, let's plot the two intercepts at negative 1, 0, 5, 0. Let's also come up with the y-intercept at 0, negative 5. Now, by the way, if I were to draw the axis of symmetry that goes through the vertex, has the equation x equals 2. So here's the idea behind that. If you look at the y-intercept at 0, negative 5, this distance is 2. So if I go the same distance 2, then I pick up a point with the same y coordinate. And that's exactly what we have here. 2 and then 2 to the right 4, giving you the same y coordinate. That's how we come up with this point, everybody. So 2 points to the right, and that gives you that. Now you just put them all together, and x equals 2 is the axis of symmetry. So you got everything that you need to come up with the graph. What dimensions will yield the maximum area of a rectangle of a perimeter 60 inches? First, let's do the drawing. This is the width x. This is the length y. We know the area is x times y, and the perimeter is just add up the sides, 2x plus 2y. So we write, we want to maximize the area, which is x times y. And we know what's given, 2 times x plus y is 60. So the very first thing is to solve for y. One easy way, get rid of the 2 and make this 30. Then move the x and y becomes 30 minus x. Put it into this equation and you get 30x minus x squared. I like to put this in descending order. And notice what we are dealing with. We have a function which is quadratic with respect to x. And if you graph it, it's a parabola that opens down because a is negative 1. Therefore, the maximum occurs at its vertex x equals minus b is 30 over 2 times a, which is negative 1. And that gives us positive 15. This is 15. And if you plug it in here, y becomes 15 also. So x is 15, y is 15, and the area is the product of the two 225 inch squared. As always, word problem, we answer it with proper units, and bear in mind 15 inches. What it means is that a rectangle has a maximum area when it becomes a square ultimately. Solved by the square root property. Even if they didn't say that, we should know the property, and that's the fastest and easiest way. The square root property basically says if x squared is a, x is plus minus square root of a. So if I take a square root of this, this comes out as 2a minus 5, and this is plus minus square root of 12. Twelve is the same as 4 times 3. 4 comes out as 2. Divide both sides by 2, and you're done. Same thing happens here. We take a root of both sides. The left side becomes x plus 1/2, and the right side is plus minus the square root of 4 over 9, which is 2/3. And the plus minus remains. Move the 1/2, we have negative 1/2 plus minus 2/3. And we need to subtract 2/3 from negative 1/2. We need to add to it. So how do we do that? Just as an example, if you add these two, use a different color. You notice that the common denominator is 6. So negative 1/2 becomes minus 3 over 6, and negative 2/3 becomes minus 4 over 6. We get negative 7 over 6. And in this case is a negative 3 plus 4 over 6. One over 6. So we can combine them, we must. What happens in this case, we move the 45. We take a root of both sides, and that's what we get. Now, this is the product of negative 1, 9, and 5. Now, negative 1 under the radical, you get rid of it and you put an I outside, 9 becomes 3. It's important to know this I is outside. If you have any doubts, put it in between. That's why in many texts, they put it in between to tell the reader, definitely this I is outside the radical sign. It's up to you. So you may see it like this. Make sure it's not in. Solve by completing the square. Well, here's the idea to help us understanding how we solve by completing the square. A perfect square trinomial is a trinomial that can be expressed as the square of a binomial, such as x squared minus 10x plus 25 is x minus 5 squared. Notice that in every perfect square trinomial, the constant term is the square of 1/2 the coefficient of the x term, or b over 2a. In other words, look at this one. This is b, minus 10, divided by 2, negative 5. If you square it, you get positive 25. That's the meaning of that. So half of this, square it. Therefore, we move the constant and we add b over 2 squared to both sides, and then we go to the previous step, which was square root principle. In this case, we move the 7. Now b is number 6, divided by 2 is 3, square it becomes 9. So add 9 to both sides. Now what's important to understand is this. On the left side, you always have x plus b over 2. b over 2 happen to be 3, including its sign, whatever it is. So it's x plus 3 quantity squared. They add up to 2. So if you take a root, x plus 3 is plus minus square root of 2. Move number 3, and we are done. Now bear in mind, this is the precise answer, and you can leave it like that. If they want an approximation, square root of 2 is about 1.41. You subtract it from negative 3, that's one answer, and then you add it to negative 3, this is the second answer. Okay, but this is an exact answer. All right, we do the same thing here. First, we get rid of negative 4. We move it to the other side. The other one is that whatever the variable, in this case is z instead of x, it doesn't matter. The a must be 1 to work out, so divide both sides by 2. So there are two steps. You want to get rid of the constant c, you move it to the other side. You want to get rid of a, you divide by it. And now we are ready to go with the next step. This is b. We want half of that. Half of a fraction, you multiply the denominator by 2, so minus 7 over 4. And then square that, positive 49 over 16. So this is the process. Again, because it's a fraction, half of that means multiply the bottom by 2. Square it, negative goes away, 7 becomes 49, 4 becomes 16. We will add that to both sides. And how do we write this? We write the same variable. Instead of x, we need z here. And remember what sits next to it, b over 2, including the sign, so minus 7/4. And the right side, you add them up. Bear in mind that this number 2, because the denominator for the next one is 16, is 32 over 16. And therefore, we get 81 over 16. Also, again, this, just the way it is, including the sign, b over 2, we put it here. So what's inside, it's plus minus the square root of the right side. 81 gives you 9, 16 gives you 4. And so you need to add them up. So as an example, just to make sure we understand what happens here, 7 over 9 plus 9 over 4 is 16 over 4, which is 4. And if you subtract them, seven over 4, you get negative 2 over 4. Negative 2 over 4 is negative 1/2. And so again, 7 over 9, 7 over 4, plus 9 over 4, and 7 over 4 minus 9 over 4, we get those two numbers. We want to use a quadratic formula to solve this, and we have ax squared plus bx plus c equal to 0. X is minus b plus minus a squared of b squared minus 4 is over 2a. A is 2, b is 4, c is 1. Plug in. We're going to plug in. So this is 16 minus 8. Which gives you 8, and that changes to 2 square root of 2. It's important to take the common factor of 2 out. And we have the answer. Part B works in the same manner. A is 7, B is 4, C is 3. Plug in. And under the radical, we get negative 68. Now, negative 68 is the product of negative 1, 4, and 17. Negative 1, we change it to I outside, 4 becomes 2. Again, we take a common factor of 2, and 2 drops. This becomes minus 2, this drops, and this becomes 7. In this case, number 1, move the 5 to the left. You cannot use the quadratic formula unless everything is on the same side. A is 2, B is 4, C is negative 5. Plug in. So we have 16 plus 40, which gives us 56 under the radical. This is the product of 4 and 14 again. 4 comes out as 2. The 2 drops because you take a common factor of 2. This changes to -2. This goes away and this becomes 2. And that's the final answer for here. We bring them to the same side. We have a choice of solving it just the way it is, or if you let r squared, you have a choice. If you let r squared be anything you want, such as x, let's say, then you're looking at x squared minus 8x plus 15 equal to 0. However, you may see that it works out just like that. So r squared minus 3 times r squared minus 5, simply because we want two numbers. The product is 15, the sum is -8. So r squared is either 3 or 5, or becomes plus minus square root of 3 plus minus square root of 5. There are 4 answers. In this case, you really have 2 choices. You can multiply both sides by b squared, or you can let b to the power of -1 be a variable of your choice. And when you do that, it's important to see if this is x, then b to the power of -2 is x squared. We've discussed the factoring when a is not 1, and since this is +1, it makes it easy. Both of them must be 1 or -1. 6 is either 2 times 3 or 6 times 1. We'll do the job. X becomes 1/2 here and 1/3 here. Now, the meaning of b to the power of -1 is the reciprocal. In other words, this means 1 over b equals x. Or b equals 1 over x. So the reciprocal of each number is the answer. 1/2 becomes 2, 1/3 becomes 3. And it's really a good practice that you check. Let's say you start with number 2 and you work it out, and then number 3. If you work with number 2, it becomes 6 times 2 to the power of -2. That means 6 over 2 squared minus 5 over 2 plus 1. You prove it's equal to 0, and you work out with the next number. It is always a good practice to check and recheck. Same thing happens here. If you choose x to the power of 1/3 to be any variable except x, then x to the power of 2/3 is square of that. So if you choose that to be m, then this is m squared. So m squared equals 2m plus 3. Move everything to the left. So this is minus 2m because we moved it to the left, and 3 becomes -3. We want two numbers. The product is -3. The sum is -2. We have the following, and m is either 3 or -1. Now bear in mind, we want to solve for x, which means you have to raise this to the 3rd power in order to get to x. X is m cubed. Therefore, 3 cubed is 27. That's one answer. -1 cubed is -1. That's the second answer. And as always, check. Put 27. X to the power of 2/3. That means 27 to the power of 2/3 equals 2 times 27 to the power of 1/3 plus 3. Check it out. And do the same thing with -1. This has to be checked. Although it says solve by substitution, even if it doesn't, that's a better way of doing it, simply because can we do it differently? Yes, square this and then combine like terms, and it takes much longer. Because this is the same as this one, both of them are 3x minus 4. Let something represent that, such as y or any other variable except x. So you have 2y squared plus y minus 1, and do the math here. Now you need to factor. This is y plus 2 times 2y minus 1. Again, the reason it's simple because 2 is a prime number is 1 and 2, and negative 1 is just 1 and negative 1 in some order. So y is either a negative 1 or 1/2. So we are going to replace the y with 3x minus 4. So 3x minus 4 is either negative 1 or 1/2. If we move the negative 4, 3x becomes 3. If you move the negative 4, positive 4, that means 4.5 or 9/2. So this gives you 3, this gives you 9/2. If you divide this one by 3, you get 1. If you divide this one by 3, you get 3/2. And again, as always, you can check, at least you can check with one of them to make sure you're in good shape. Now, what if we want to go back? In other words, the solution is given and we want to see what is the function or the equation for that matter. So if we are not given a variable, normally we choose x, but you can choose anything. Let x be this number and that number. Move the numbers to the left. This is 0, so is this one, and so is their product. I hope you remember that a minus b times a plus b is a squared minus b squared. Therefore, x squared minus, when you square this one comes out, x squared minus 3 is 0. If they were asking for an equation, you would be done. Since they are asking for function, you call this f of x. And now you're done. Now we have a nonlinear inequality we want to solve. The very first thing we do, we factor. If we were to set it equal to 0, regardless of what this says, less than, greater than, less than or equal, greater than or equal, it doesn't matter. Find the zeros or what makes it undefined if it happened to be an expression of such. And those are called critical points, important points. This gives you 1, this gives you -5. You go with a number line. So x at -5, f of x becomes 0. At 1, also f of x becomes 0. Now, all you have to do, pick up test points. You can pick up test points anywhere. One thing that happens, because none of them has exponent which is even, if you find any of them, the other one's alternate. But for example, by the way, the easiest one, believe it or not, would be between the two is 0. So if you plug in 0, everybody, first of all, if you plug in here, it becomes minus, so that's negative. If you plug it here, negative times positive is negative. So we want the sign. Over here, let's say we choose -6, and over here, let's say we choose 2. And so what do we do now? Put -6 in here. You can do it here or here. It's easier to evaluate it here. -6 goes here, becomes negative here, and negative times negative is positive. If you plug in 2, both of them are positive. Positive times positive is positive. So positive, negative, positive. And again, as I said, you should see why it alternates. So we go back to the question, we want greater than or equal. So wherever we see positive is the answer, which means from, remember, it's from -∞ to -5, union 1 to infinity. And the endpoints are included. The reason we use brackets for -5 as well as 1, because equality says so. If we didn't have equality, we would use parentheses. Now, if you look at this question, I am using the same factors. One is at top, one is at the bottom, which means if I go through the process, remember, negative times negative is positive, also negative over negative is positive. So it will give us the same result, but it is slightly different, and that's what I want you to pay attention to. At -5, we still get 0 because it's at top, but at 1, we get undefined because you can't divide by 0. So undefined. With that being the case, we get the same result there. And how do we answer it? Now, basically, we answer it in the same manner. The difference is -5 makes it 0, so that's fine. But 1 makes it undefined, so that's not fine. You go with the parentheses. So I want you to pay attention to this one and the difference between the two and why. Other than that, everything is the same. So a sine graph will do the job for us. A model rocket will be launched from a hill 80 feet above the sea level. The launch site is next to the ocean, and the rocket will fall into the ocean. The rocket's distance S above the sea level is given as such. We want to find the time it takes for the rocket to strike the ocean. Simply put, and this is a question from physics, the height will become 0, so set S of t equal to 0 and solve it. It's a very simple case. Find the time it takes for the rocket to strike the ocean. And this is the height. Well, set it equal to 0, factor out the -16. T squared minus 4, t minus 5, it's an easy factor. T is either 5 or -1. By the way, it doesn't matter what you have here. It makes no difference. And of course, time can't be negative, or at least not now. So the only answer is t equals 5 seconds. Frank drove a distance of 300 miles one way. The round trip took him 11 hours. If he averaged 10 miles per hour faster on his return trip, find his average speed going and returning. Number one, this is a class of problem known as motion problem. Which means D equals RT. So if D equals RT, R is equal to D over T, and the T equals D over R. So first and foremost, come up with this and make sure you have everything in there. So we are going 300 miles one way. So the distance is 300 miles here and 300 miles coming back. The total time is 11 hours. So it's going to take us 11 hours. And if he averaged 10 miles per hour faster on his return trip, we don't know the speed either way, but we know that if we use X for this one, this will be more by 10. So X and X plus 10, the units are miles per hour. So what is the time? According to this formula's time is D over R. So 300 over X here, 300 over X plus 10 here. And they must add up to 11. So I hope you see, if you have a word problem, you set it up in this manner, you can easily come up with the answer. I can't emphasize the importance of that. So with that being the case, you multiply both sides by LCD, which is X times X plus 10. So this gives you 300 times X plus 10 plus 300 times X, and the right side, you just write it. This is 300X plus 3000 plus 300X. This is 11X squared plus 110X. These two, they add up to 600X. We are going to move everything to one side, which means this goes this way, becomes minus 600X, and this becomes minus 3000, and there you have it. You can do it by any method, including factoring. The factoring is doable simply because 11 is a prime number. So 1 and 11, we have really no choice. And 50 and 60, the product is 3000. One of them is negative. So X is either 50 or negative 60 over 11. We can't have it negative. So 50 miles per hour is here. This must be what? 50 plus 10 or 60 miles per hour. And it's easy to check because 300 divided by 50 is 6 hours and by 60 is 5 hours. They add up to 11 hours. So the beauty of math is you can check and you must. So word problems, this is an example of a motion problem, which becomes a quadratic equation. The base of a triangular sign is 5 feet less than 3 times the height. Find the base and the height if the area is given as 25 square feet. So if this is the height, this is the base, and the base is 3h minus 5, according to what we just read. So this is the height, this is the base. The base is 3 times h minus 5, and the area is half of base times the height. I hope everybody knows this formula. So just plug in, replace the base with 3h minus 5. We want to solve this. This is a fairly simple equation to solve. First, get rid of the 1/2 by multiplying both sides by 2. So this changes to 50. Now you have 3h squared minus 5h equals 50. And bring the 50 to the left. So we can factor it as h minus 5 times 3h plus 10 equals 0. H becomes 5, h becomes negative 10/3. Sides cannot be negative, so that's out. The only acceptable answer is 5. So if the height is 5, the base is 3 times that, 15 minus 5, or 10 feet. Does it make sense? Half of 5 times 10, is it equal to 25? Yes, it checks. We are fine.